So we're going to evaluate functions involving double angles. And so we're going to use this information to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So this would be a tad bit lengthy, but not too bad. Nothing that we can't handle because we're all super nerdy here. So we're given that the cosine is 5/13, and that theta particularly is in the fourth quadrant. This is in between the 3π/2 and 2 pi. So what we need to do here is create a right triangle. Okay, so I'm just going to do that over here. So if I have these two guys, I'm going to go ahead and create my triangle. You know, it's going to be somewhere over here, right? I mean, they don't say specifically, but it's going to be in this quadrant. So just like that there. All right. So I know that we're in this quadrant. This is my theta, and it tells that cosine is 5/13. So that's adjacent over the hypotenuse, right? So all I did was I just created a right triangle using this information. We can solve for our missing side. We've seen this special triple triangle many times now. This must be 12. Okay, this is a 5, 12, 13. However, do not make the mistake of leaving this positive, because this coordinate point right here is the point 5, -12, right? If I go over 5, down 12, that means it has to be a -12. Very important there that you understand what quadrant you're in so you know which values are positive and negative. Well, in that case, now like all we got to do is just, you know, write out our formula for each of our double angle formulas, and then we can plug it in. So for example, sine of 2 theta is 2 times sine theta cosine theta. Well, this is not hard, right? 2, what is sine of theta? Well, sine is opposite over hypotenuse, so I can just replace sine of theta with -12/13. -12/13. Right, that's no problem right there. And we can replace cosine with 5/13. Okay? So using your calculator, just multiply these all out. The exam next week you will be able to use the calculator here. So just multiply all those out, and you get -120 all over 169. And that's what you get right there. All right, so check off. Bing! Now let's find cosine of 2 theta. Now what's really cool with cosine of 2 theta is that we have 3 choices. We can use the cosine squared minus sine squared. We could use 2 cosine squared minus 1, or 1 minus 2 sine squared. It doesn't matter which one you use. You will get the same answer. Hi. All right, so I'm just going to use 2 cosine squared theta minus 1. All right, but you can use any of the 3 options. They're all equivalents. So 2 cosine squared theta minus 1. Well, I'm going to write 2, but then I can replace cosine again with 5/13. That's 5/13, and then minus 1. Do all that mumbo jumbo on your calculator, and you get -119 all over 169. All right. Bing. Last but not least, tangent of 2 theta. All right. Tangent of 2 theta. Okay, so we're going to do 2 times tangents of theta, and that's all over 1 minus tangent squared theta. All right, so there's no other option. They only have one double angle for tangent. So it's 2 times our tangent of theta. Well, tangent, opposite over adjacent. So we're going to multiply that by -12/5. All over 1 minus tangent squared. So -12/5. Doing all that mumbo jumbo on your calculator, you'll get 120 over 119. Bing! And we just found sine of 2 theta, cosine 2 theta, and tangent of 2 theta.